Hey guys, make sure y'all have something to write with, and we're going to get started on scientific notation. So we've already discussed exponential notation, which is just an easier way for us to write multiples of numbers. So in that same way, scientific notation is used to represent very large or very small numbers and make it easier for us to write them. And the reason it's called scientific notation is because it is used really often in science, because they are often dealing with very large or very small numbers. So for our first example, we're going to have a large number, and I'll show you how we can convert it into scientific notation. So let's say we have 8,700,000. Now that's a pretty big number, and in some cases we might want to write it in a smaller form. So to do that, we're going to, so for this number, the decimal is right here, and we're going to move the decimal over until we get right before the very last digit of this number. So we're going to move the decimal over that many places, and we're going to count how many times we moved over that decimal. So we moved it 1, 2, 3, 4, 5, 6. So we moved the decimal over 6 places, and we moved it to right before this very last or very first digit in the number. So the way that we would write this in scientific notation is we're going to include any of the non-zero numbers. So in this case, we're going to write 8.7. And then we're going to write times 10. And the exponent here is going to be however many times we moved the decimal place over. So in this case, it's 6. So for this number, it's 8.7 times 10 to the 6th is the way that we would write that. Now we're going to give an example of a very small number. So let's say we have 0.000. So this is a very small number. It is less than 0, so it's a fractional number, but we have it written as a decimal. So first we're going to move the decimal place all the way over. So it's right here. And we're going to move it all the way over until it is right after this very first non-zero number. So it's right after the 4. We're going to count how many times we moved it. 1, 2, 3, 4, 5, 6, 7. So the way that we would write this is 4.3, because we include all of the important non-zero numbers, times 10 to the negative 7. So our first number that we converted was a really large number, and if you're looking at where 0 is on the number line, so past the decimal, the large number was to the left of the decimal. Our small numbers are to the right. When we're writing smaller numbers in scientific notation and we're moving the decimal to the right, the exponent is going to be negative. So we're going to have a negative exponent. When we have very large numbers and we're moving the decimal to the left, we're going to have a positive exponent. So you can look at numbers in scientific notation and know that numbers with a positive exponent are greater than 0, and ones with a negative exponent are less than 0. So now we're going to go over a few examples and get you a little bit more used to writing your numbers this way. So this first one, we have convert 93 million to scientific notation. So first we want to think about whether or not this is a big number or a small number. So this one is a big number. And that means our exponent for our scientific notation is going to be a positive exponent. So the next thing we're going to do is move the decimal place 7 places. For this specific number, we're going to move it 7 places to the left. So we have 93 million. I'm going to move the decimal place 1, 2, 3, 4, 5, 6, 7 places. So we moved the decimal over 7 places. So now I want you to write that in scientific notation. So we would write it 9.3 times 10 to the 7th power. Good job. All right, this next one we have 0.000000036. And the first question is this a big or a small number? It is a small number. And that means our exponent will be negative. So we're going to move the decimal to the right until we get right after the first non-zero number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved it over 9 places. So how would we write that in scientific notation? It would be 3.6 times 10 to the negative 9. Now we're going to do some practice for writing numbers in scientific notation. So our first one, we have 43.8. So we're going to move the decimal 1 place to the left. So it will be right after our very front number. So we have 4.38 times 10, and we moved it 1 time, so it's 10 to the first. All right, our next one, we're going to move the decimal 1, 2, 3, 4 places till it's right after our very first non-zero digit, and we'll write it 7.46 times 10, and we move the decimal 1, 2, 3, 4 times. And because this is a very small number, because it's a small number, we know our exponent is going to be negative. All right, this one, 1, 2, 3, 4, 5, 7.78 times 10 to the negative 5th power. $140, we have the decimal would be right here, so we'll move it over 2 places. 1.4 times 10 to the second. 0.191, that's going to be a number that's smaller than 0, so we'll have a negative exponent. So we'll move the decimal over 1 place. We have 1.91 times 10 to the negative 1st. And we have 8,400. We'll move that decimal 1, 2, 3 places. And we have 8.4 times 10 to the 3rd. So going from scientific notation back to standard notation, you basically just do the opposite of moving the decimal. So here we have 9.8 times 10 to the negative 1. Now we know because our exponent is a negative, we know that this number is going to be less than 0. So if the answer we get is greater than 0, then we've done it incorrectly. So since this is 10 to the negative 1 power, we're going to move the decimal over to the left 1 spot. So our answer is 0.98. For this next one, we have a positive exponent, which means this is a number greater than 0. So if the decimal is right here, we're going to move it over 1, 2, 3 times. And our number is 8,000. This one, we have a positive exponent. We have 8, 1, 2, 3, 4, 5. $800,000. This one, we have a negative exponent, so it's a smaller number, and we're going to move the decimal over to the left, 0.94. And this next one, we have a positive exponent. We're going to move the decimal to the right. So we get 43.9. And then our last one, we have a negative exponent, so it's less than 0. So we have our 2, and our decimal is right here. And we're going to move it 1, 2, 3, 4, 5 places. So we have 0.00002. Good job.